Hi guys, let us understand today normalization. What are the different form of normalization and what is the denormalization? And we will also have a look on the EF chord rule here. So you can look this one, normalizations. So normalization is the process of eliminating duplicate or redundant data in a relational database design. So whenever we are designing our database, so we have to be careful, and if you use normalization concept, your database will be having less wastage of memory and it will have a good performance. So next, redundancy of data causes. So if you're having a redundant data, then inconsistency problem due to changes. So insert, update and deletes. If it is not normalized, and if you're going to insert data, if you're going to update data, if you're going to delete data, so in that case some inconsistency will creep in. Okay, next, wastage of storage space. So if you are having some repeating or repeated data, in that case there is a wastage of memory. So what exactly normalization is, that it is a step by step decomposition of complex record into simple record. So if we are having a bigger table, we can make a small table and we can relate it to each other. Okay, so we can break in a step by step. Okay, and that reduces redundancy using the principle of non-loss decompositions. So we have to decompose our table into several smaller table in such a way so that there is no loss of data. So non-loss decomposition is the reduction of a table to a smaller tables without any loss of informations. Even again, there is no hard and fast rule that you have to do this. If you're thinking that if I have introduced this column and this stuff, then there is no loss of data, you can go for that, right? So a fully normalized record consists of a primary key and a set of attributes that describe the entity. Okay, so let us understand all these types of normalizations. Before understanding this normalization, let us understand this stuff first. Consider you are having a table where you are maintaining some kind of a student details and all, instructor details and there. So we are having some instructor here, instructor name is there, and some student name is here, right? So this is instructor name, and here is a student name, a student number, right? And there's some address. So this table satisfies the properties of relation and is said to be in a first normal form. So consider this table is a 1NF, and conceptually it is a convenient to have all the information in one relation, since it is then likely to be easier to query the database. But the problem will come. What I mean, if you are keeping everything in single table, or I mean it is in a one relation or one table, lot of problem will come, and that is called anomalies. What is that? There's a first anomalies, repetition of information. Another is the update anomalies, insertion anomalies, and deletion anomalies. These are the four anomalies we are having. So if we talk about repetition of information, a lot of information is being repeated here. Like a student name, you can see Smith is coming three times, right? Address, course name, instructor name, and office number, sorry, are being repeated often. So you can clearly see here the repetition of office number right here, and address. Okay, now so every time we wish to insert a student enrollment, say in CP302 here, we must insert the name of the course, right, as well as the name and office number of its instructor. Also, every time we insert a new enrollment for say Smith, we must repeat his name and address. Repetition of information result in wastage of storage. So we can try some trick so that this repetition will not happen. If one student has come, okay, he can do the several courses, different courses, but it's not repeat this information, right, here. So unnecessary, we are wasting the memory here, right? Next thing is what? Update anomalies. Redundant data information not only wastes or waste storage but makes updates more difficult. Since more example, changing the name of the instructor of CP302 would require that all tuples containing CP302 enrollment information be updated. So if I want to change the instructor for this guy, like I want to change another instructor, okay, then I need to take this information, and if I go to changes, it might affect the whole other records also get changed because all these three are the same student number, right? So if for some reason all tuples are not updated, we might have a database that gives two names of instructor for subject. This difficulty is called the update anomaly, right? Insertion anomalies. Inability to represent certain information. Let the primary key of ever relation be student number and I can say course number. Any new tuple to be inserted in the relation must have a value for new primary key. Since existential integrity requires that a key may not be totally or partially null, right? So however, if one wanted to insert the number and name of a new course in the database, it would not be possible until a student enrollments in the course and we are able to insert values for of serial number and course number. So what it mean if I want to introduce a new course here, course and course name, so I cannot do here. In that case, I have to maintain this null, right? Unnecessary, we have to maintain a null. Other thing, if I'm not maintaining the null, then I need to enter a student here, right? So that could be the insertion anomalies. Okay. So however, if one wanted to insert the number and name of a new course in the database, it would not be possible until a student enrollments in the course and we are able to insert values of serial number and course number. So information about a new student cannot be inserted in the database until the student enrolls in a subject, right? We cannot introduce any record unless and until some registration happen. We have just launched the course, so we cannot expect immediately, right? These difficulties are called insertion anomalies. Next is the deletion anomalies, loss of useful information. In some instances, you can think like useful information may be lost when a tuple is deleted. For example, if we delete the tuple corresponding to a student 8500 doing CP304, we lose relevant information about course CP304, right? We are deleting which number? CP304, right? We are just removing the course, but we lose related informations about course. Okay, if the student 8501 was the only student enrolled in that course. Similarly, deletion of course from the database may remove all information about the student. So if I remove this course, this whole line will get removed, right? So that information may lost, right? So because of this anomalies, we decompose the table into multiple